So this is the first video on implicit differentiation. And what we want to do is find just the first derivative of the following equation. Some things that we need to keep in mind is that implicit refers to an equation that is not explicitly describing y as equal to some product or to some polynomial or other terms, such that y will always equal the sum product quotient total of the other side, meaning that explicitly describing what y is equal to. What we are working with are implicit. Implicit is what we see here. Oftentimes we may see that it is something like this, which is implicit in that we have two variables and we are not easily able to isolate this for one or the other, especially for y. So if we're trying to find a value x on the x-axis and then determine its height y in relation to y, we wouldn't be able to do that as easy. So we're going to use rules for implicit differentiation in order to solve this. And something to keep in mind is that we are treating y within this implicit, we are treating y as a function of x. And hopefully that will make sense as we walk through this. And this isn't exhaustive. I'm hoping that at this point you've definitely read through your book and of course attended some courses on this to get a better understanding. But we can take, and the second part of this is that we can take the derivative when we're trying to find it, we can take the derivative of both sides of the equation. So just like in basic algebra, what you do to one side, you need to do to the other side of the equation. So in looking at this, x times y equals 1, we definitely have a product. So the first thing that we're going to need to do is apply the product rule to this. And we of course could see that we could isolate for y in this particular equation, but we're going to use those rules for implicit differentiation. So we're going to say that this is the derivative with respect to x of xy is equal to the derivative with respect to x of 1 on the other side of the equation. Now, the product rule states that we're going to take let's take the derivative with respect to x of the first times the second plus the derivative with respect to x of the second multiplied by the first. And I'm always going to use these parentheses or brackets, although with addition it's okay if you forget, but if you're not in the habit of doing that and we end up with a quotient, you're going to end up subtracting, and without those parentheses, that's going to make a big difference when you go to combine like terms. So in this case, we have this set up as a product on the left side, so we can solve the derivative of 1 on the right. That's going to be 0. Now we can further look at this from the derivative of x, which is just simply going to be 1 multiplied by y plus the derivative, and this is what it literally says. We're saying that we want the derivative of x with respect to x of y. And what's interesting is that this is literally just the derivative y with respect to x. These are equal. That's what this says. So what we're going to end up with, is just dy, derivative y, with respect to x, bringing this down. So multiplied by x equals 0. So when you finally, if you do see the derivative with respect to x, the derivative of y with respect to x here, you're just thinking, okay, well that is dy dx. That's really what you're after. And it won't always be that way. A lot of times that y will be raised to a power. So in this case, we do end up with just dy dx times x. So now we can reduce this a little bit, and we're going to have y plus x dy, derivative y with respect to x. And let's treat this as a term in the numerator. Let's not make this a fraction such that it would be x times dy over dx. And you'll see why we don't want to do that. It's definitely a term in the numerator, so we're going to treat it as that. And then on the other side, of course, we still have 0. So now we want to at this point, we want to isolate for dy dx to one side of the equation. So let's go ahead and subtract y from both sides. So minus y, and we will have x dy dx is equal to negative y. And of course, we can then divide by x. And as you can see, it might have been confusing if you didn't know that we're just treating dy dx as a term in the numerator. You would be thinking, okay, well, this x, how does it relate to the x in the dy dx? You don't. You just go ahead and put your parentheses around it, treat it like a complete value, because it really does, it is a placeholder for a complete value or expression. So we're going to divide by x on both sides, and we're going to end up with dy dx is equal to negative y over x. And now I'll show you how this can also look if we had simply taken the original x times y equals 1, and we had isolated for y and then just took our standard derivative rules and applied those. So we are going to do that next to it here. So we had x, y equals 1. We would just simply isolate for y, which means that we would divide by x on both sides. And we would have y is equal to 1 over x. And you might see that there is a difference. There is a difference here for the derivative. So when we take the derivative of y equals 1 over x, we say, okay, this is going to be the derivative y with respect to x for 1 divided by x. And then we would use the quotient rule. And we're going to use the quotient rule as x times the derivative of 1 minus, and we will just put 1 here, and we will do the derivative with respect to x for x, all of that, over x And of course, this is x squared. And we get x times 0 minus, and here's where those parentheses are really important, minus 1 times 1 over x squared. This is gone. This is just -1. And we end up with -1 over x squared. So let's take a look at how these are the same. Remember I said that y equals 1 over x. Well, let's substitute that back in. Let's substitute that back in for the implicit form. We're going to say that dy of dx is equal to negative, and we had y is equal to 1 over x. So we go y, substitute in 1 over x for y, over x, and then let's multiply by the reciprocal of the denominator, and we have negative 1 over x multiplied by 1 over x, and that gives us a negative 1x squared. So what we found by doing this side by side is that this, the implicit form of dy dx equals negative y over x, is the same as the dx equals -1. I'm sorry, dy is equal to -1 over x squared. They are the exact same derivative. This is the first derivative. So hopefully that helps in the basic understanding of what an implicit differentiation is, how to find your derivative of an implicit, and of course, how that correlates when we're finding explicit forms, which we did on the right side, how they are the same. So thanks for watching.